Every second of our lives, we are attacked by billions of bacteria, viruses, and fungi. The body has many ways of defending itself against pathogens. When a pathogen does infect the body, our body's defenses, called the immune system, are triggered and the pathogen is attacked and destroyed. Vaccine plays an important role in strengthening the immune system through introducing an antigen in the form of attenuated or weakened living virus that actively replicates in the body in order to generate immunity. Newer vaccines contain the blueprint for producing antigens rather than the antigen itself. Once the body produces antibodies in its primary response to an antigen, it also creates antibody-producing memory cells. This means that if the person is exposed to the dangerous pathogen in the future, their immune system or the antibodies can remember faster and more effective in responding immediately and kill it before it produces harm. This is what we call long-term adaptive immunity to pathogen. How long the protection lasts of these vaccines? Some vaccines like COVID-19 vaccines can only protect for a short period and may need a booster doses. How do vaccine boosters work? Booster shots strengthen or maintain immune responses to combat outbreaks and restore the protection which might decrease over a long period of time due to age and the vulnerability it needs to have a sufficient, prolonged protective immunity both individually and across the wider population. Booster doses often fill in those gaps. This figure shows B cell responses to primary or initial vaccination and to antigen boosting. B cells are one of the types of immune cells. Vaccine-induced primary B cells responded to the antigen. A germinal center reaction follows, which allows for the proliferation and selection of B cells of increasing affinity for vaccine antigen. Antibodies produced at this initial stage of vaccination are usually in moderate affinity despite of accumulation of high affinity memory B cells. This is when vaccine booster plays a vital role. At time of boosting with the homologous antigen, high affinity memory B cells continually reproduce antibodies even in presence of persisting antibodies and compete for antigen with low affinity naive B cells. The final result is the production of antibodies of higher affinity. Always remember that when safety is first, you last, so have a booster shot.